And I'm very happy to announce the one and only fungal speaker of today, and he also happens to be my student, Tristan Wang from Harvard University. Tristan?
Hi everybody, my name is Tristan. I am an undergraduate at Harvard working with Dan and Haelewaters and on Pfister's lab. We work with an order of Ascomyces called Laboulbeniales. It's a group of fungi characterized as ectoparasitic fungi that grow on insects and other arthropods. Specifically, I focus on fungi that grow on cockroaches. Alright, don't get too excited now, guys. I'm safety of the presenters. Over here, you see a lateral view of a cockroach with this antennae sticking out from behind. These white little stubs you see that's covering the entire antennae, those are what we call phalli of Laboulbeniales, or the fungal bodies. But before we go into more about fungi, let's go over through a brief introduction. So in this presentation, I'll cover a brief life history of ecology and morphology of Laboulbeniales in general. And then later on, we'll go into the research that I've been doing in Don Pfister's lab, including ecological, taxonomic, and phylogenetic work, specifically on two special species that I hold dear to my heart. So the pressing question is, what are Laboulbeniales? It's a good question. So Laboulbeniales is a large order within Ascomycota. They consist of over 2,000 different species, which makes it the largest group of ectoparasitic fungi that grow on insects and arthropods. They infect insects ranging from like beetles, to flies, to ants, it's my favorite, cockroaches, but they also infect mites and millipedes too. What's so interesting about this group of fungi is that unlike other fungi within Ascomycota, the Laboulbeniales shows a phenomenon called determinate growth, meaning that there's only a certain number of cells and cell divisions before the fungi itself stops growing, which is highly unusual of the group. So this threshold for size often doesn't exceed like 1 to 3 millimeters in length, so they're super tiny, as you can see here and there. If you enlarge one of these pictures of Laboulbeniales, you'll see something similar to this, the morphology of a phallus. This is a sample of Herpomyces chaetophilus, one of the species that we work with. Typically, the fungi attaches itself, it anchors itself to the exoskeleton of insects through a structure called foot cells. And this large oval portion up here, that's connected to the foot cells through a series of cells called the receptacle. That's a female structure that houses the two-celled ascospores. These spores later on are ejected through an opening called the operculum on top. Male spermatia, that's generated through a male structure called an antheridium. In our genera, they occur on different individuals from the female parathecine. So foot cells usually insert these hair-like structures called haustoria into their host. And you can see it more clearly in this picture, actually. And these haustoria, they tap into the insect's hemolymph, sap away like whatever nutrients they need. But of course, like Laboulbeniales are really picky eaters, like myself, for example. So they usually, Laboulbeniales are species specific, meaning that there's usually one fungal species that correlates to one other insect species or insect host. Although it's not unheard of for Laboulbeniales species to infect several hosts simultaneously. There are, for example, Laboulbeniales species that infect beetles and infect the mites that infect the beetles. So it's like super infections in many cases. Wow. So, you might be asking yourself right now, what could be grosser than fungi that feed on beetle juice? Well, I'll give you a hint. We don't work with butterflies in Don Pfister's lab. Here's an American cockroach, actually. Ah, so beautiful, isn't it? So we're going to delve into the research we've been working on a couple of fungal species that infect cockroaches. So everything started out, people often ask me, like, why cockroaches of all insect species? Why not like moths or like caterpillars? Well, everything started with the cockroach that we found in the basement. It's in the Phylogenetic. Here's the Phylogenetic, where Don Pfister's lab works. Underneath the building, there's a large mechanical basement, which is hidden underneath the wooden floors. And last summer, during a heavy rain, Don Pfister actually recommended for me and Danny to look into the basement for any floating cockroaches, common victims to Bostonian floods. And after screening through a dozen cockroaches, I actually found one thallus sitting on the head of a cockroach. Danny actually identified it as Herpomyces chaetophilus. And he actually told me that every other cockroach I screened were also infected, but my eyes were not trained, and they're still not very trained to this point. He said that there were actually 2 species infecting these cockroaches, as you can see from here, Herpomyces chaetophilus and Herpomyces periplanate. What's so interesting about these species is that a famous mycologist by the name of Pfister described over 1,000 species of Laboulbeniales. I was like, that's a lot. And what's so cool is that he actually described Herpomyces chaetophilus. And he worked at the same building that we work now, in the Farlow Herbarium. But he didn't see any of this chaetophilus in Boston at all, even though he screened a bunch of cockroaches within the building and in Boston. So that single thallus that we found on that summer rainy day, I was actually the first record of the species in North America. How cool is that? So after screening through several dozen cockroaches, we came up with some preliminary statistics. About 97% of these cockroaches were infected with Herpomyces chaetophilus. That's a phenomenal amount. That's nearly every cockroach being infected, even though Roland actually did not report this species at all within Harvard. And the other species, periplanate, range about 2/3, about 65% infection rate. We also bought cockroaches online. So expensive. And for some reason, we didn't find any infected Carolina cockroaches from the Carolina Biological Company to be infected with Herpomyces chaetophilus, although they had a very similar infection rate of periplanate. We don't really know why. Maybe it's because their colonies were just not exposed to outside cockroaches and did not catch on to Herpomyces chaetophilus. We're not really sure. But these are the 2 infections. And it just so happened that these 2 fungi often co-occurred on the same cockroach. And of course, because nearly every cockroach was infected with Herpomyces chaetophilus, every cockroach that had periplanate happened to be a double infection. Now, what's so interesting about these double infections is that these cockroaches, these fungi, seem to be actually position specific. So they seem to specialize in infecting certain parts of the cockroach. Like they claim their territory. It's like, oh, this is my part of the cockroach. Stay away. So what's really interesting is that even though Herpomyces chaetophilus, Latin for hair-loving, only occurs on the hairs of cockroaches, they occur on nearly every part of the cockroach body, including its head, legs, abdomen, parts of its butt. And periplanate only occurs on the antennae and rarely occurs elsewhere. Even though chaetophilus was much more prominent in my studies, I see every cockroach, nearly every cockroach is infected with Herpomyces chaetophilus. So as you can see here, I found 9 cockroaches that had over 100 thalli of Herpomyces periplanate, and there's only 1 cockroach with such a high infection for chaetophilus. Meanwhile, most cockroaches in their antennae were not infected by Herpomyces chaetophilus, more so than periplanate. So in terms of phylogenetic analyses, I have some genetics you can see. We found out that Danny did some interesting work, and he found out that there was only a 97% similarity in the 5.8S region within the fungal genome, which according to the fungal barcode of life is enough to delineate 2 distinct species. So even though these 2 fungi, which sometimes occur within micrometers of each other on the same cockroach, they just happen to be 2 different species, as you can see here. And our research doesn't end with these 2 species. One of my main goals for my senior thesis is to actually compile a list of all ectoparasitic fungi that grow on cockroaches. So we've been screening through the Natural History Museum at Harvard and in New York, and only it's a few hundred. We've only screened through a few hundred, but that's going to grow much larger soon. I'll see a lot more cockroaches soon. And we observed about 13 infected cockroaches within 2 genera. And what's really cool is that here's a picture of a cockroach called Archimandrida tessellata, which has never been before seen to be infected by Laboulbeniales in its genera. So this is a new record, actually, which is, I find, kind of cool. But what I'm really excited for is some of the ecological work that we'll have been doing with Laboulbeniales. So far, there's only been one mycologist by the name of Howard Whistler, who in 1986 was able to culture the Laboulbeniales in an accentic culture, meaning that there's no obligate host within the region. But he was only able to do this to the immature 20 cell stage without a female parathecium. So one of my goals is to actually be able to culture these Laboulbeniales without its host. So I've been garnering a bunch of cockroaches from Harvard and asking my friends to donate their insects to me from their dorms, which they happily do, so that I can have enough spores to grow these Laboulbeniales. With these cockroaches, I also intend to do some cross-infection experiments between the American cockroach and a couple other cockroach species that we have in the vivarium right now. So in order to create a culture, well, you need to know what is the specific contents of the hemolymph of the cockroaches. Howard Whistler, he used a specific substance called brain-heart infusion for this fungal growth. And that's what I intend to do too, soon enough this summer. Another method we're trying is by boiling cockroaches so that hemolymph directly leaches out into the media, which we'll be using as fungal food later on. So growing these Laboulbeniales can have significant impacts for the field of Laboulbeniales, mainly because now you can start studying the developmental biology of these fungi as you see them grow up. And in addition, you might be able to have a sustainable resource of these fungi without having a bunch of cockroaches in your room, 24/7 actually. In terms of cross-infection work, I have several colonies of all three of these species, the Madagascar cockroach and the German cockroach, who are not known to be hosts to Herpomyces chaetophilus or Paraplanidae. Cross-infections don't happen naturally in the wild too often, or else you see them all the time. Mainly because maybe there's temperature differences, humidity differences, maybe just geographical barriers preventing contact. So if you were to put all these cockroaches in the same tube within the same environment, is it possible to have a cross-infection between one species and another? Or is it something more innate, like within the hemolymph that's providing a barricade between cross-infections? That's something to find out soon later. So people have told me all the time that cockroaches are dirty, disgusting, and disease-carrying critters. And after doing research on a bunch of cockroaches for a year, I gotta admit that they were right. But there's a fine line between disgust and charisma. And cockroaches often order the former than the latter. But I'm really excited for our future research in terms of ecology and biology. Thank you very much. I would like to thank the Natural History Museum of Harvard and New York, and Danny Haelewaters, who introduced the field of Laboulbeniales to me. Thank you.
But that's not it. Further discussions should happen during the break.
Sure. I also have cockroaches you guys want to see. Yes, question.
I just wondered what effect the infection has on the cockroach.
Unfortunately, not very much. They are the perfect parasite because they don't really harm the host at all, which also means that they don't have too much of a significant implication in terms of pest control. That was my biggest concern too. Like, wouldn't it be fantastic to get rid of all the cockroaches, right? To infect with fungi. Well, there were some studies done, and turned out that affected populations and unaffected populations kind of did very similarly, unfortunately. Although, yeah, I would love gel-like pest control. Unless you have anything else to say.
I have a quick question for you. So you say that Herpomyces chaetophilus grows only on the hairs. Do you have a biological or mechanical reason for that, or explanation or hypothesis?
Not really sure. Here you can, there's an extra slide. Here you can see like all Herpomyces chaetophilus, they grow solely on the hairs. We don't really know why they only grow on the hairs, as opposed to Paraplanidae, which can go directly onto the cockroach. Yeah, we don't really know. But what's really interesting is that all these fungi, all these they're always oriented outwards, distally, away from the cockroach body, which is super ideal for the fungi, so that they can emit their spores later on. We don't know why they do that though. Maybe it's the stream of hemolymph, the direction, or maybe it's because of the grooming of the cockroach that pulls the hairs of the antennae out. More research has to be done.
Okay, well, thank you, Tristan.